Day 218 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again, and today we have question number 138, copy list with random pointer. The difficulty level is medium, but we're going to keep the solution as simple and easy to understand as possible, so let's get into it. The question says, a linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list or null. Construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value of its corresponding original node. Both the next and random pointer of the new nodes should point to the new nodes in the copied list such that the pointers in the original list and copied list represent the same list state. None of the pointers in the new list should point to new nodes in the original list. For example, if there are two nodes x and y in the original list where capital X dot random points to capital Y, then the corresponding two nodes x and y in the copy list is lowercase x dot random points to lowercase y. Return the head of the copy linked list. The linked list is represented in the input/output as a list of n nodes. Each node is represented as a pair of val random index where val an integer representing node.val and random index the index of the node range from 0 to negative n minus 1 that the random pointer points to, or null if it does not point to any node. Your code will be given the head of the original linked list. So let's break that down and see what they mean. But right now, the most important part is we have to construct a deep copy. And what that means is we're going to have to open up new space in the memory for our linked list that we're about to create. The linked list cannot use this original list. The list that we create cannot use the original list. We have to create a brand new list that takes up brand new space in the memory, which is important for the deep copy, right? And that's where it gets a little tricky because, say in this case, right, where we're looking at example 1 here, say in this case, right, where this node, or excuse me, the third node points to right here, the fifth node, right? Or the third node, the random pointer in the third node points to the fifth node, because remember, these random pointers can point to anywhere. See, this random pointer, the first random pointer points all the way to node. See, we have the next pointers, which go just next like a regular list node. But we also have these random pointers where this random pointer doesn't point to the next node. This random pointer points all the way to null. Then we come right here to the second node, and the next node does what it's supposed to do, goes to the next node. But the random pointer comes back and points to the first node. And then this third node right here, next node goes next, but the random pointer points to the fifth node, and that's where it can get tricky, because when we're creating the pointers, we won't be able to just point this third node to the fifth node, because the fifth node hasn't even been created yet, and that's where it can get tricky. However, that's why we're going to use two passes, and the pass is just when we iterate through it one time, right? So we're going to have to iterate through it twice. The first time we're going to iterate through it, that's going to get us all the nodes that we need, and then the first pass is going to get us with all the nodes that we need, and then the second pass is going to allow us to point the random pointers to where they need to go, because we've already created the whole list and through the first pass, right? And we're going to be able to do that using hash maps. So let's look at these examples, but as you can see with these examples, we're really looking at the random nodes, and because the input and the output are going to be the same, the only difference is they're going to have to take up two different spaces in memory, and we're going to have to create a brand new list. So it's not going to be as easy as just copy and paste. And now let's look at example 2, where it's the same thing, right? We have the input head is 2D array. First array 1 1, second array 2 1. Then the output is the same thing, 2D array. First array is 1 1, second array is 2 1. It's the same thing because we're just copying it, but we're making a deep copy, and that's where it gets tricky. Same thing for example 3. Excuse me, y'all. Where the input head equals 3 null, 3 0, and 3 null. And so what this is, just so we know, the 3 right here is the next pointer, boom, points to next. that's the next pointer, but the null represents the random pointer, right? So the first node points to null. Then right here we have example. In the second node it's 3 again. It points to the 3, but the random pointer points to 0, which is right here. And then same thing with here. This node is 3, but the random pointer points to null like this, but the output is going to look the same as the input. So now that we understand the question, let's get into the fun part, the actual code. The code is not as hard to understand as the question. Before we get into the code though, y'all, if y'all need any new Apple AirPods, go ahead and check out that link in the description. Then after you do that, go ahead and like, comment, and subscribe. So let's get into it. First thing we are going to do, we're going to declare a variable. We're going to call that new head. We're going to that's going to be a node. Excuse me, y'all. That's going to be a node, optional node. Then we're going to come down here, declare another variable called that node map, and that is going to be an array or a hash map, of nodes. The key is going to be a node, value is going to be a node. We're going to initialize that with a blank dictionary like this. Then we're going to come down here, declare another variable called optional node, and we're going to set that equal to the head. Then we're going to come down here, we're going to say while let node equals optional node, open up the brackets, we're going to say let new node equal node map, square brackets, node, come outside of that, question mark, excuse me y'all, node. Then we're going to open up the parentheses, we're going to say node dot val, node dot val. We're going to come underneath that and we are going to say if new head is equal to nil, what we're going to do, we're going to say new head equals new node, just like that. Then we're going to come underneath that if statement and we're going to say node map, square bracket, node, come outside that equals new node, just like that. Then we're going to come underneath that, we're going to say if let next equals node.next, open up the brackets, we're going to say let new next equal node map, square brackets, next, question mark, we're going to say node, open up the parentheses, next dot val. Then we're going to come down here, we're going to say new node dot next equals new next. Then we're going to come right here and we're going to say node map, square bracket next, square bracket next equals new next. Then we're going to come out underneath that if statement, we're going to say if let random equals node dot random. I'm going to open up the brackets and we're going to say let new random equal node map, square bracket, random, come outside of that, question mark, node, open up the parentheses, and we are going to say, we're going to say random dot val. Then we're going to come underneath that and we are going to say new node dot random equals new random. Then we're going to come underneath that, we're going to say node map, square bracket, random equals new random, just like that. Then come outside of that if statement and we are going to say optional node equals node dot next. Then after that we're just going to come down here and we're going to return new head, just like that. Let's run it, see if it runs like it's supposed to. We got an error, can't find node. Excuse me, y'all, this should say node like that. So let's run it again. Should have checked all the errors, but let's see, cannot find random. Little typo there. Let's see what else. That should be the last one. So let's run it this time. See what happens. Let's see. And it's accepted. So let's submit it. Make sure it stays accepted after we submit it, because we all know how this LeetCode stuff can get. And look at that, y'all. 21 milliseconds beats 15.29% of users with Swift, y'all. Now, don't worry about those numbers. We'll get those up as we continue down our LeetCode journey. Right now, we're just focused on understanding the question and understanding the code that was written, so we can apply the knowledge that we learned today on our future LeetCode problems. And then as we get better and further down our LeetCode journey, we'll start to worry more and more about the time complexity. But with all that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.